Ever wondered why soldering can sometimes feel like a high-wire balancing act? Well, that's because it is. It's a delicate process that requires a fine balance of several factors. First off, maintaining the correct temperature is crucial. Too hot, and you risk damaging the components. Too cold, and the solder won't melt properly. It's a bit like Goldilocks porridge, it has to be just right. Then there's the application of flux. This chemical cleaning agent ensures a clean, oxide-free environment for the solder to flow smoothly. But apply too much or too little and you're in for a world of trouble. And let's not forget the common defects like cold joints and bridges. These occur when the solder doesn't melt completely, or when it connects two points that shouldn't be connected. They're like the uninvited guests at a party, always showing up when you least expect them. Given these challenges, wouldn't it be great if there was a way to make the soldering process more precise and consistent? Before we reveal the solution, let's first understand the process of soldering. Soldering is a fascinating marriage of science and technique. It begins with the careful application of heat, which must be just right. Too little, and the solder won't flow; too much, and you risk damaging the components. Next, we introduce flux, a cleaning agent that removes oxidation from the metal surfaces. This step is crucial, as it ensures a clean and secure bond between the solder and the components. Then comes the star of the show, the solder itself. This alloy, often a blend of tin and lead, is delicately applied to the joint. Precision is key here. Too much solder can cause bridging, while too little can result in a weak joint. Each step in this process requires meticulous attention and precision. Now imagine if we could use AI to optimize this process. Yes, you heard it right. Artificial intelligence, or AI, can indeed optimize the soldering process. How, you ask?